What's up guys, Sam here. The Google quantum computer has far outpaced ordinary computing technology, an achievement called quantum supremacy that's an important milestone for a revolutionary way of processing data. Google disclosed the results in the journal Nature on Wednesday. The achievement came after more than a decade of work at Google, including the use of its own quantum computing chip, called Sycamore. In the blog post the Google researchers was said, "Our machine performed the target computation in 200 seconds, and from measurements in our experiment, we determined that it would take the world's fastest supercomputer 10,000 years to produce a similar output." Nearly every digital device so far, from ENIAC in 1945 to Apple's iPhone 11 in 2019, is a classical computer. Their electronics rely on logic circuits to do things like add two numbers and on memory cells to store the results. Quantum computers are entirely different, reliant instead on the mind-bending rules of physics that govern ultra-small objects like atoms. Where classical computers store and process data as individual bits, each a 1 or a 0, quantum computers use a different foundation, called a qubit. Each qubit can store a combination of different states of 1 and 0 at the same time through a phenomenon called superposition. Not only that, but multiple qubits can be ganged together through another quantum phenomenon called entanglement. That lets a quantum computer explore a vast number of possible solutions to a problem at the same time. In principle, a quantum computer's performance grows exponentially. Add one more qubit, and you've doubled the number of solutions you can examine in one fell swoop. For that reason, quantum computing engineers are working to increase the number of qubits in their machines. But qubit count isn't everything. Unavoidable instabilities cause qubits to lose their data. To counteract that problem, researchers are also working on error correction techniques to let a calculation sidestep those problems. But it's not the beginning of the end for classical computers, at least in the view of today's quantum computing experts. Quantum computers are finicky, exotic and have to run in an extremely controlled environment, and they're not likely to replace most of what we do today on classical computers. So for now at least, quantum computing, while radically different. Thanks for the watching. Don't forget to subscribe. I will come with new video. Be Sam.